Have you ever looked up at the night sky and wondered just how far can we see? The stars we glimpse are only our cosmic neighbors, a handful of light years away. The most distant objects in the universe lie so far beyond them that their light has traveled for billions of years just to reach our eyes. These aren't just faraway points of light, they're windows into the past, showing us the universe when it was young, wild, and utterly alien. To understand these distant objects, we first have to grasp how astronomers measure such impossible distances. Unlike measuring the space between cities or even planets, cosmic distances require clever tricks. One of the most important tools is redshift. As the universe expands, it stretches the light traveling through it, shifting it toward longer, redder wavelengths. The more distant an object is, the more its light has been stretched. By measuring this redshift, astronomers can calculate not just how far away something is, but how long its light has been traveling to reach us. The current record holders for the most distant objects are galaxies so ancient that we see them as they were just a few 100 million years after the Big Bang. One of these, Jade's GSC 1320, appears to us as it existed a mere 300 million years into the universe's 13.8 billion year history. Its light has taken over 13.4 billion years to reach Earth. But due to the expansion of the universe, it's now an estimated 33 billion light-years away. That means the light we see today, the galaxy, when the universe was a fraction of its current size, and space itself has stretched tremendously in the time it took that light to reach us. What's astonishing about these early galaxies is how quickly they formed. The universe began as a searing hot soup of particles, and yet, within a few 100 million years, gravity had already pulled together the first stars and galaxies. Some of these ancient galaxies are surprisingly bright, suggesting they were forming stars at a furious pace. How did they grow so fast? Did dark matter help clump them together sooner than expected? Or were the first stars fundamentally different from the ones we see today, burning hotter and dying younger? Each discovery raises new questions, challenging our understanding of cosmic evolution. Even more baffling are quasars, the blazing cores of distant galaxies, powered by supermassive black holes. The most distant quasar known, J0313-1806, dates back to when the universe was only 670 million years old. What's staggering is the size of its black hole, over a billion times the mass of our Sun. How did something so massive form so quickly? Black holes grow by consuming gas and stars, but even under ideal conditions, it should take much longer for one to reach that size. Its existence suggests that the early universe had ways of feeding these monsters that we don't yet understand. Beyond galaxies and quasars, the most fleeting yet powerful distant objects are gamma-ray bursts, brief, catastrophic explosions marking the deaths of massive stars. The most distant gamma-ray burst ever detected, GRB 090423, occurred when the universe was just 630 million years old. For a few seconds, this dying star outshone entire galaxies, sending a pulse of energy across the cosmos that we detected more than 13 billion years later. These bursts are like cosmic flashbulbs, briefly illuminating the early universe before vanishing forever. Yet, as far as we've seen, we may still be missing the very first generation of stars, known as population 3 stars. These would have been made only of hydrogen and helium, the elements forged in the Big Bang. They would have been enormous, short-lived, and incredibly bright, ending their lives in violent explosions that seeded the universe with heavier elements. So far, we haven't definitively spotted one, but the James Webb Space Telescope, with its unparalleled infrared vision, might finally reveal them. What's truly humbling is that every photon of light from these distant objects is a message from the past. When we observe a galaxy 13 billion light-years away, we're seeing it as it was before Earth even existed. The universe was a different place then, smaller, hotter, and filled with the raw ingredients of everything we know. And yet, against all odds, we found ways to glimpse that ancient era, piecing together the story of how it all began. The search for the most distant objects isn't just about breaking records, it's about understanding our origins. Each new discovery pushes the boundaries of what we thought possible, revealing a universe that's stranger and more wondrous than we imagined. And with every advance in technology, we peer a little deeper, uncovering more of the cosmos's oldest secrets. The farthest objects we see today may one day be surpassed by even more distant ones, reminding us that the universe still has countless stories left to tell.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.